Today I am going to present about a topic on stepper motor in industrial applications. Then this is the list of contents. First one is introduction, then second one is construction, then stepper motor step calculation and working, how the stepper motor works and how to calculate the step and how the stepper motor is working, then the multiple stepper motors, then driving techniques, then what are all the types of stepper motor, then how to select the stepper motor for the various industrial applications, then advantages and disadvantages of stepper motor, then industrial applications of stepper motor. Mainly stepper motor is used for robotic applications. Then first one is introduction about stepper motor. Selection between the servo motor and the stepper motor quit will be challenged with balancing of several design factors of cost consideration, torque, speed, acceleration, and drive circuitry are the important role in selecting the motor for the applications. So that is the main constraint about stepper motor. The price will be very high because the design is very complicated. Then torque, then speed, acceleration are the important role in selecting the motors for the applications. And what is stepper motor? A step motor or stepping motor is called step motor. It runs step by step only, okay, in which the single rotation is divided into the number of steps. Each step is being calculated by an angle. The step angle can be varied as per the design of the motor. Then the construction of the stepper motor. It has a permanent magnetic rotating shaft called the rotor and stationary electromagnets surrounding the rotor called the stator. Also, it has typically 100 electromagnet poles of north and south poles generated either by a permanent magnet or an electric current. Each permanent magnetic pole is having a natural stopping point, and the position of the poles is placed in the stepper motor position itself accurately and precisely. This is the convenient features of the stepper motor in that the poles of the stepper motor is allowed to position accurately without any positional feedback. This is the diagram which shows the stepper motor. This is the 3D view of the diagram of stepper motor. The first diagram shows the fully covered stepper motor. Then the second diagram shows the cross-sectional part of the stepper motor. It shows the shaft, then bearing, then winding, then stator, then end cap. Then the important part is rotor section. Then the main part is permanent magnet. The magnet is called permanent magnet. Then the rotor section, then front end cap. End cap is used to protect the rotor and magnetic field poles. And when we want to increase the resolution which achieve the smallest rotation moment, designed for a stepper motor contains a large number of magnetic poles. Basically, the incremental step size of the motor is fixed to the cylinder greaves rotation based on the number of electromagnetic poles. Therefore, moving to an acceleration position is simply a matter to sending the commands to the pole of the stepper motor. Then next, the important topic is stepper motor step calculation. The stepper motor has 200 rotor teeth and 200 to 400 4 steps for the revolution of the motor shaft. To determine the resolution of the rotation of the motor, we can perform a little max. If the stepper motor has 200 incremental steps and we know the 4 rotation is equal to a circle where 360 degrees. 360 degree divided by 200 step is equal to 1.8 degree. Then the each step angle is 1.8 degree. Suppose if we want to 400 step in 360 degree means The step size is 0.9 degree. This is the step angle, stepper motor step calculation. The next one is position 1. The rotor is started at the top of the electromagnetic pole, which is current energized with the current flowing through a wire. In order to move the stepper motor in clockwise, the top of the electromagnetic pole will be deactivated. This is the position 1 of the stepper motor. Then position 2, 3 and 4. Now the top of the electromagnet will be deactivated and the right side of the electromagnet is activated, carrying a rotor to move 90 degree clockwise and align with the active magnet as shown in the position 2. Now it is continued to deactivate and activate the electromagnetic poles around the stator and position 3 and 4, carrying rotor to align with each new electromagnetic pole to enable to rotate the rotor 90 degree in clockwise in each time. This eventually completes a fourth 360 degree of rotation. Hence, remembering the basic properties of the electromagnetic pole, repels and low and unlike poles attract depending on the power source current is applied to an electromagnetic pole coil wire. It causes like and unlike magnetic attraction and retraction forces in the permanent magnet to rotate the motor. The diagram shows the position 2, position 3 and position 4. In the real world, the stepper motor incorporates a large number of electromagnetic poles on the stator and rotor to increase the resolution. With the increase in the number of electromagnetic poles, the operation is basically the same as the example providing 90 degree rotation. The pulses are given below. It shows the A, B and A dash, then B dash. Then the second one is multiple stepper motors. Refer to the below mentioned animated working principle of stepper motor with multi-step action. So this is frame 1. The coil is designed in the upper portion 1 with the top stator electromagnet 1 will be activated. It attracts the nearest geared pole in the rotor. Then the rotor starts rotating. They will slightly offset from the right electromagnet. Then frame 2. The top electromagnet 1 is deactivated and the right side of the electromagnet 2 will be activated. Then pulling the teeth into alignment with it. That is, consider we have 100 steps motor. It gives 3.6 degree of rotation for each steps. Frame 3. The bottom coil 3 is energized. 1 and 2 will be deactivated. So this is the diagram. Hence, another 3.6 degree rotation occurs. Then last one is frame 4. The left electromagnet 4 in the stator is energized. 1 to 3 will be deactivated. Hence we get another 3.6 degree rotation. Again the top coil of stator 1 will be enabled. Then the same process continues one by one. By energizing and de-energizing of the stator electromagnet, we get 360 degree rotation. By fastening the electromagnetic polarization, we can increase the speed of the motor. Then next heading is driving techniques. The stepper motor driving techniques can be possible with some specific circuits due to the complex design. There are several methods to drive this motor. Some of them are discussed below by taking an example of the 4-phase stepper motor. Then driving techniques. The first one is single excitation mode. The basic method of driving a stepper motor is a single excitation mode. It is an oldest method and not used now at present. but one has to know about this technique. In this technique, every phase, otherwise stator next to each other, will be triggered only one way alternatively with a special circuit. This will magnetize and demagnetize the stator to move the rotor forward. The next heading is full step drive. Then second topic is half step drive. Then next one is micro stepping. This is most frequently used due to its accuracy. The accuracy of every step can be enhanced by the small step current. This technique is extensively used because it provides high accuracy. It decreases the operating noise. So most of the stepper motors are used in micro stepping. Then the types of stepper motor. First one is permanent magnet stepper motor, then hybrid stepper motor, then variable reluctance stepper motor. The first one is permanent magnet stepper motor. It uses a permanent magnet in the rotor and operate a attraction or repulsion between the rotor and the stator is electromagnet. This is the most common type of stepper motor as compared with different types of stepper motors available in the market. This motor includes permanent magnet in the construction of motor. This kind of motor is also known as stack motor. The main benefit of this stepper motor is less manufacturing cost. For every revolution, it has 48 to 24 steps. Then second one is variable reluctance stepper motor. Variable reluctance stepper motors have a plain iron rotor and operate based on the principle that minimum reluctance occurs with minimum gap. Hence, the rotor points are attracted towards the stator magnetic poles. The stepper motor, like variable reluctance, is the basic type of motor and it is used for the past many years. As the name suggests, the rotor angular position mainly depends on the magnetic circuit's reluctance that can be formed among the teeth of the stator as well as rotor. Then third one is hybrid synchronous stepper motor, named because there are a combination of permanent magnetic and variable reluctance stepper motor. The most common type of motor is a hybrid stepper motor because it gives a good performance. This type of stepper motor is expensive compared with permanent magnet stepper motor. These motors are used where less stepping angle is required 1.5, 1.8 and 2.5 degrees. This is the step angle degrees. Then how to select a stepper motor? Before selecting the stepper motor for your requirement, it is very significant to examine the torque speed curve of the motor. So this information is available from the designer of the motor and it is a graphical symbol of the torque of the motor at a different specified speed. The motor torque speed curve should match closely the necessities of the application. The diagram shows the various stepper motor. Then the advantages and disadvantages of stepper motor. Advantages: simple construction, it works in open loop control system, the maintenance is low, it works in any situation, reliability is high. Then the disadvantages of the stepper motor is torque of the motor will decline fast with speed. The dedicated control circuit is necessary. Operation of this motor is not easy at very high speed. As compared with the DC motor, it uses more current. The motor is not controlled properly, then the resonance can occur. Then the industrial applications of stepper motor. The main applications of the stepper motor in industry is 3D printing equipment, robotic arm, textile machines, printing presses, gaming machines, medical imaging machinery, small robotics, CNC milling machines, welding equipment, etc. This is the industrial applications of the stepper motor. In this diagram it shows the robot. In the robotic arm, the stepper motor is used. The robotic is used to count the number of wooden sections. A stepper motor is a digital electromechanical system wherein each electrical pulses input moves the rotor by a discrete angle called the step angle, and hence the naming stepper motor. Stepper motors are used universally for numerous applications in industrial areas. Robotics is one of the areas where the use of stepper motor is one of the utmost importance. Robotic applications require precise movements for accuracy. The stepper motor is suitable for robotic applications because its movement comprises of discrete steps. The drive system of the stepper motor controls its movements. The versatile drive system will allow accurate control of the movement of a stepper motor so that it can be used in robotic applications. Many authors have proposed driver circuits for stepper motors. However, the design circuitry proposed does not have a user-friendly approach. And then this is the diagram shows the two-phase permanent magnet stepper motor drive model. The stepper motor driver is simulated using MATLAB. Stepper motor driver is simulated using MATLAB Simulink Sync Power Systems. Shows the signal builder, then load torque, then the permanent magnet stepper motor. The next one shows the parameters of the permanent magnet stepper motors: step angle, winding resistance, winding inductance, number of phases, then total initial speed, inertia, then total friction. We are all entered with the specific boxes. Then click OK. Then by clicking the scope, it displays the waveform. This is the signal builder dialog boxes which shows the step and direction of the stepper motor. Okay, this is the simulation waveform. In the stepper motor model consists of permanent magnet stepper motor block, a driver block, a signal builder block, a DC voltage, and a scope that gives the results of the simulation. Thank you.